everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark and this is episode number 9. So currently we are recording on New Year's Day, so a massive happy New Year to everyone. Hopefully at some point this year we'll be in a better situation as far as you know what is concerned. So today I'm joined by Simon Painter to talk all about functional programming in C#. And if Simon's name rings a bell, it might be because in episode 6, Simon was one of the 5 guests who talked all about the DDD conferences. So welcome back to the show, Simon.
Hello, kids.
I don't know what to say to that. Oh, dear. So for those who missed your intro in episode 6, could you give us a quick intro into your background, who you are and what it is you do?
Sure. Hello, my name is Simon and I'm an no, wrong meeting. Hello.
It's going to be one of those shows, is it?
And I'm not. I've been enjoying myself this new year. It's been one of the few saving graces, considering that we can't flip and go out or do anything. No, hello. My name is Simon. I've been a software developer for, I think it is a little over 15 years now. I've worked for a whole load of very different places over the years, doing pretty much exclusively C#, .NET, so on and so forth. I've done some government stuff for HMRC, and I've done The Works. That's a book place, which is probably familiar to most folks that live in the UK because there's one on pretty much every street corner. And I'm currently working as a developer for Müller, that is being the folks that make the rather delicious yogurts. I've been promised at some point I'll be giving a tour of the factory, which I'm looking forward to, and also free yogurt. I am really looking forward to the free yogurt.
I just realised I think I've always pronounced it incorrectly as Muller. Is it Müller then?
Well, to be honest, an awful lot of the people that work for us do say it the same, but it is in fact Müller. It's a German company and it's correctly spelled Mueller or MU with 2 dots over it, LLER. It's a German letter that we don't have, so just sort of U, which if you have any German letters there, they're probably busy throwing stuff at the speaker at the moment, telling me I've got it quite wrong, but I think I'm roughly right. It's close enough that the folks in Germany can understand me.
Nice. So we were supposed to be recording this yesterday, weren't we, Simon?
Yeah. Yeah. So what happened was we had an appointment that had been set up for days that Dan had sent to me and reminded me about. And then at about 12 o'clock, my wife said, how about we go take the kids to the town park? And I, without even thinking for a second, thought, yeah, what a good idea. It's a nice day. And I was sitting in the play park with the kids while they ran around doing whatever it is they do. And I was doing whatever it was. I was doing mostly Pokemon Go. And got a message from Dan saying, yes, I'm online now. Let's go. What are we doing? And suddenly the whole place felt an awful lot colder, paradoxically. What would it be so cold? And I realised that I had been what is called in technical circles a nitwit. And completely forgotten.
It was okay. I was fine. I was just sat on my own on New Year's Eve in a Zoom chat, staring out of the window, watching as the snow slowly fell to the ground with a little shiver, knowing that I'd been abandoned, stood up, just wondering if perhaps I should just wait one more minute, just in case. What an end to the year that was 2020.
Oh no, oh dear. Although you need that piano music from The Incredible Hulk, that's what you should be having now. Dun, 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 dun.
Sorry, I really couldn't resist. You did say I could add some sound effects, so...
I did say that. Oh dear. Yeah,
it's all good. I was actually really knackered yesterday, so you did me a favour. I'm feeling much better today. So, and in fact, I can now say Happy New Year.
Ooh.
It's 2021. So have you any New Year's resolutions planned?
I am a massive nerd, as anyone who's ever met me will attest. So I usually set out New Year's goals. I usually make a whole list of about 10 or 12 items of things I intend to do within the next year. I haven't sat down to do it yet, and it's possibly because I took an opportunity while the kids were busy to go and do a quick crossword. But at some point today, I decided to take the opportunity that we got from lockdown to start learning the piano. So I'm sort of vaguely around a grade 3, so I expect to try and get to a grade 5. That would be that would be nice in the next year. Technical wise, though, I really want to learn React because it has been on my. I've got a short list of technologies I've been planning to learn for years, and React has been fairly consistently either number one or very close to it. And I've dabbled a bit, but I've not enough. I probably know about enough to be dangerous, but not enough to sort of sit down and blast out a React project from nothing. Although, Dan, you and I had a conversation the other day on Twitter, and possibly got some really nice hints now on how to get started. So I have made a little go at starting on that. I'm sure there's. Yeah, I've got a couple of talks I'd like to get cracking. I really want to learn to get more into machine learning. That's been bubbling higher and higher as the year's gone on in terms of how really important it is to possibly to all of us to start at least being aware of it, if nothing else. So that's something I want to get into a lot. I don't know. I'll probably think of some other things, some very stupid projects I've got on the side as well.
Yeah, I did a little. I think it was earlier last year. I'm saying last year, like the year we just had a short talk on. In fact, no, it was the year before because it was in person. A short lightning talk on ML.net, and it was because I wanted to play around and learn it. So I decided to do a lightning talk just to force me to learn. And it's super simple. It's pretty much a wizard, and you click through. And I think that's probably the way machine learning is going, where you can just use it without fully understanding all the maths behind it.
I completely agree with you, but I don't know if it's a deficiency in me or what, but I've never been able to cope with that. If someone just says click the wizard, click, choose that option, and it works, that's great. But I always really like to know what's going on under the surface. Otherwise, I don't feel like I really know how to use it. I'm just sort of letting the wizard do its thing. So I think until I've sat there and sort of implemented a load of the algorithms myself, just so I really understand them, I think I won't be comfortable with ML.net.
Just to clarify, though, when I said ML.net is a wizard, there's actually a component of ML.net called the model builder. It's this that's the wizard, which generates .NET code using the ML API. But even so, it's still probably not as low level as you're talking about.
It's probably going to be an on and off project for the next year, and it doesn't help that you do need to understand some really higher maths. And I like maths, and I've always liked maths. But I've learned maths up until, there seems to be like an imaginary barrier where you sort of pass this point in maths, and then we've gone away from just, here's some maths like you knew at school, but complicated, and into, here's the new and incredible world of theoretical maths, where you've got to learn all of this new notation and all of this new terminology, and there's really wild, mind-blowing concepts to learn. And it all looks fabulous, but oh my goodness, I need to sort of... I possibly need to learn how to not sleep, so that while everyone else in the house is out, I can actually get some work done. Because having a family with small kids, it's really hard to get anything really complicated accomplished.
I think having kids certainly doesn't help with getting stuff done. That's why I try and get up super early, but they do too, which is unfortunate.
Not if your partner also wants you to spend time with them in addition to your side projects. No, so it is which is a totally reasonable request considering we've been busy at work, then busy with the kids all day. Maybe I can spare what little time I've got left, but and it's all fine. But I do also wish I had more time on top of all of that. So, like I said, learn React or whatever.
I'm quite lucky that in my current contract, we're doing .NET and React as well. That's kind of where I've learned the React stuff we were discussing the other day. It's quite fun. It's nice and functional, funnily enough.
Yeah, the dabbling I've done with it in the past, it looked like it was going deeply down that way of thinking. I did get a really simple project done gosh, it would be something like 3-4 years ago, I think it was, in React as was, and I think it's moved on quite a lot since then. If nothing else, the infrastructure around it has moved on. It used to be you had to do a lot of work to get a React project even to start working in the first place, and I think a lot of that pain is gone now. But yeah, I dealt with what was it called? Was it Flux? The Flux architecture,
Yes.
and that looked really interesting, and I was enjoying playing with that. And like you say, it is all very functional stuff, all this single direction flow of data and all that. But I never got very deep into it, and the company I was working for never adopted it. So of course, like a lot of things, it's kind of got left by the wayside, and I'm not sure how much of it I can really remember not to be able to code in anger with it anyway.
I think there's lots of different patterns, and you don't have to use them all. So React, quite common, is you would use Redux on top of it. And you don't have to use Redux, though. It's effectively just an in-memory data store doing what you were describing about single directional events. But you don't have to use that to use React. One thing I quite like with React is talking about functional programming, where the older versions of React, you would create components as classes, where now they recommend using something called functional components, which is just a function, and it gets rid of things like this dot and that class having state, and it's much more designed to be functional the way it works.
That looks like something I need to look into. Of course, part of the other problem is I'm at that point with React that I don't know what I don't know. So, and there's article, and as is always the case with the internet, you write an article which is totally top of the line and like the most cutting edge you can be, and then 6 months down the line, it's out of date already, but that article stays in existence forever. So you go find, how do I do X in React? And you will find articles all over the flipping shop, all written in varying styles of programming and various at various times, and it's hard to know what's still current and what's not. And and of course you've got the usual problem that you always have in programming. Like when I started back some time ago, I thought, well, okay, I know C# now. I'll just learn how to do it properly. Oh well, yes, learn how to do it properly. It's been 15 years. I'm still trying to do that, and it's kind of that in microcosm with React in a way. Like, what's the correct way to do it? I don't know. Probably no one person does, because there's no one answer to that question, and it's going to be a learning curve, like everything else we do in this business.
The pattern that I find most important, or the acronym, is KISS. Just keep it simple. And I won't say what the last word is. But
yes, I am aware of that last word.
So I remember when you did your first functional programming talk at .NET Oxford, the user group I run.
Yeah.
And at the time, the closest I'd gotten to functional programming was just being a big fan of LINQ. But then you started introducing terms such as option, either, maybes, which we can certainly dig into a bit later. I must admit, though, at the time, I hadn't realized that these were official functional programming terms from other languages. I think that was probably because you were creating your own implementations of option, either, maybe, classes manually. And I thought these were terms that you made up as part of your examples. And then at the end, you mentioned a book called Functional Programming in C#, which I then went on to read. And as I read this book, I realized that these were official concepts from other languages that you were talking about.
Yeah, no, absolutely. And just for clarity as well, the book in question is Functional Programming C# by Enrico Buonanno, published by Manning. There's another book with the same title, which is still a good book, but I particularly like the one by Buonanno, the Manning book. That is possibly one of my very favourite programming books that I've read in possibly ever. It's certainly likely to sit on my in the top couple of positions in my virtual bookshelf. So yeah, I do recommend anyone that's vaguely interested in what we're talking about to go check that book out. Other books are available. But read that one. Seriously, read that one. No, yes, you're absolutely right. I'm not sure if I'm entirely comfortable with official terms, because I don't believe there is any official spec on what functional programming is and what names to use, because I arbitrarily used some versions of the naming convention, but actually just about every functional term you can imagine, I think it seems to have at least 2 or 3 alternative names. But I've heard option either, I've heard the other names for that, and something I've heard that called just, and a few other things, and some. But yeah, Absolutely. No, I did not invent. If anyone gets the chance to watch my talk, I didn't invent any of it. None of that. Deeply unoriginal talk in an awful lot of ways. In fact, functional programming doesn't even date back to programming language. It dates back to maths. It's something that came out of the maths world, and I did want to do a deep dive into it to see if I could include it in my talks, some talks on the exact origins of some of these concepts. And it seems to date back ultimately to the late 1800s in maths texts that I haven't the slightest chance of being able to understand. But the more immediate basis of it comes from about the 1950s, where you got folks like Alonzo Church is one of the names I tend to big up. He's the chap that we owe lambda expressions to and a few other things. The crossover between maths and computing is probably something that started early, and it's still going on, but I don't think it's it's not quite as obvious these days as it used to be, but it's always been there. Yeah, all this stuff dates back way, way back, and that's, in fact, the first programming language, the first functional programming language was from the 1960s. It was called Lisp, and I think it's still in use out there in the wide world. Supposedly, it can do some really wild stuff that even modern programming languages can't keep up with, but I've personally never used it. It looks awesome, and if someone would like to pay me huge amounts of money to work in Lisp, then I am your man, because why not? But so far, all people really want me to do is do C#, and that's fine, because I like C# a lot. But going back to your original point, LINQ, yes, absolutely. LINQ is functional. LINQ is absolutely a functional component of C#. It works in an entirely functional manner. That is okay. Do we want to discuss what functional programming even is at this point?
Yeah, I think we should definitely start at the beginning.
Sure. Okay, let's go back to the beginning, because functional programming, I mean, what a name. What, do all other programs not function? I can see why they gave it that name, but it can also be a bit misleading. For when I started to hear this term functional programming about, I thought, is this even a thing? My program functions, surely. No. It's a bit like organic food. It's a term that gives a bit of a false impression, like, is all other food not organic? Is all other food made of rocks? No. There is no one catch-all description of what functional programming is. It's more a set of properties and features. The major one being that programs, generally speaking, are composed of functions, hence functional programming. It's program. Everything is a function. In fact, there's a bit of a rule of thumb in functional programming. If there is a question, the answer is typically functions, more functions. So it's a bit of a broad statement, but it usually works. And you kind of have to imagine functions being built up like, if you imagine a function as a Lego brick, then we're building up piece by piece with layers of Lego bricks our entire application, and each function is a brick in the entire wall of the thing. And there's some further concepts that go along with it. One of the really important ones is immutability. So that means that once you've set a variable's value, you can't ever change it no matter what. Now, C# doesn't really do that. And I know there are ways of doing it, and they are kind of pushing a little in that direction. If you look at some of the new features in C# 8 and 9, then you'll find that you can get compiler warnings to turn on. And there are, I think as of 9, I have a feeling that you can even go further and start having things break in 9. I'm not totally sure on that.
In C# 9, you've got record types, which really go in that direction. So I'm looking forward to that being mainstream.
Yeah, I did the Advent of Code this year, and I used record types for that, and they're really nice. They're really nice. And that's absolutely moving in the direction of functional programming, absolutely. Look into there's this lovely stuff that you can do with record types, where it's like, I've got my record type with 10 properties. I want to just adjust one of them, and you can make a new record, which is the same as the old one, with one property changed, and that's just like one little line of code. It's beautiful, it is. Clarifies intent and just saves on so much boilerplate. I am more than slightly in love with record types.
I just hope people take them on board, because early last year I wrote a blog about writing more succinct C#, and there was definitely two camps on Twitter and the blog post replies. Those that like functional programming and were really positive about the blog post, and those that were clearly quite set in their ways with more classical, I won't say classical is the wrong word, but more object-oriented programming.
I was going to say, because functional programming, I believe, even predates object-orientated. unless someone's going to turn around at some point and tell me, I don't believe that there was any concept of object orientation before programming. I believe it's a concept that belongs to programming now, and functional is way before programming languages even existed, pretty much. Well, unless you're counting like Ada Lovelace and the programming she did, which we absolutely validly count as programming. But I think I'm talking about what we more classically conceive of as a programming language. But yeah, anyway. But definitely immutability is incredibly powerful, and it seems a little bit counterproductive when you first hear of this concept, but it is. Once you start playing with it, and once you have to then consider the implications to the rest of your program, and in that I cannot change this value, you end up writing stuff that is very, very robust, and most importantly, and for a lot of people this is the selling point, really predictable. Because if you're into automated testing, and you certainly should be if you are a good individual, then functional programming absolutely, completely supports testability, because we don't have states as such. We don't have this central state object which everyone can interact with and change and manipulate. It's not quite like that. So there is a concept in functional programming of pure functions. The other way of referring to it is referential integrity. I like pure functions just because it's a slightly friendlier term, but it means that when you write a function, ideally, that what you're aiming for is that given the same set of values in the parameter, the output should always be exactly the same out, no matter what. No matter what the state of the system is, excepting that, the computer switched on. Good luck to you otherwise. No matter how long the system's been running, no matter everything else, you get 1 and B in as parameters, you get the same answer back.
But presumably also avoiding things like database calls and any other side effects.
Yeah. And there shouldn't be any other side effects coming out of it. It's like, obviously in the real world, you can't ever really have that end-to-end in your system. It's just not, it's a thing that cannot happen. And there are varying ways of solving this problem. And certainly, otherwise you can't store data, you can't read files. There's all sorts of things that you can't do. But the aim is, though, to maximize the area of your system that works in this way, because if you've got a pure function, you can just write a load of unit tests around it, and that's it. You can 100% trust that thing to always behave in this manner, predictably, and then you can extract out as much as logic as you can from all the rest of your classes and build them in this manner, and you've got this giant blob in the center, which is really predictable and really stable. Then you just got to put some structure around the fuzzy edges of the system where strangeness can happen, interaction with human beings or file or whatever, where we have to have an interaction. But then you just sort of minimize those away to the fringes. The metaphor I usually give is there's two parts of a shadow. The umbra is the dark bit in the middle, and the penumbra is the fuzzy grey bit around the edge of the shadow. And what we want is the umbra to be as big and black and dark as possible, and the penumbra to be minimized. There's a couple of new terms for the folks at home. I quite like those ones.
Nice. I think we're going to have quite a few new terms in this episode, I suspect, especially monad. Do you reckon we can, at some point in this episode, explain what a monad is?
Maybe.
Maybe, pardon the pun.
Yeah. The thing with monads is that if you try looking around on the internet, and Wikipedia, I'm looking at you tend to get these descriptions that are mathematicians' descriptions, and there's nothing wrong with that. Maths is cool. Whatever anyone else at school might have said, maths is cool. But it tends to be the sort of heavy theoretical maths stuff, where it's like f arrow g of f of g of x is, and it's, I don't know, I just made that up, but it's stuff that I struggle really to understand, and it's stuff that I actually use all the time. So being an engineer, which is how I think of myself, the best way to describe it is an engineer's description, and that being, what's it for? How do I use it? That is how I approach any technical subject. So what's it for? How do I use it? Now, strictly speaking, most of you, yourself, Dan, and then most of the folks at home will probably find that they've actually been using monads for years and never realized. Promise is a monad down in the JS world. We've got a variation on that with the weights out in the C# world. That's a way to. A way to think of it is it's an extra layer around the execution of a function, which makes a decision on how to proceed. But even then, we're making it sound more complicated than it really is.
Is it worth starting off with a description of what these other terms we've mentioned, like options, eithers, maybes,
Sure.
and then talk about monads, because that might maybe lead into it a bit better?
Okay, well, here's the simple example I usually give when I'm giving talks is calculating the conversion between Celsius and Fahrenheit. I used to work for a company in the US, and they would say things like, it's 100 degrees outside, and I would think, ooh, that sounds to me like you would all be dead. But of course, in Celsius, if you sit and think about it, I think it's about 33, something like that. I don't know, but they are not, rest assured, or boiling to a horrible death at that time. It's quite nice temperature and rather lovely outside. Although, gosh, I've been over there in the summer. It's not a joke. But but anyway, the conversion. There's all sorts of ways, but the one I know is, here we go. It's take the Celsius, double it, subtract 10%, add 32. Woo. Which, yes, of course, why not? But the point is that we've got 3 operations being done there. Each one takes the result of the last one, does a thing, and passes out a result, which the next thing takes the result from what was done before, does a thing, passes it on. We've got a chain of operations here. It's not unlike a select statement. And in fact, if you do a series of select statements one after the other, you'll find that something like this order of operations will happen, because select don't necessarily operate in the order you think they do. But the simple way that I've got, and I believe I may have dug it out from the Buonanno book, is I created an extension method in C#, and it's tiny. It's probably no more than about a dozen characters. I called it map, but you could call it what you like. Map's as good a name as any. And the idea is that we're mapping the old thing into the new thing. And I've applied 2 generics to it. I called them something like tprev, t input something, but T to be the old type, whatever the old type was. And in my example here, they're pretty much always going to be like doubles or decimals or something. And then another T being the output type. So great. We've got the old type, the new type, and using generics, we're saying it's anything to anything. So then you attach it to this input type, the T input, the T1, T1 and T2. I've seen it called that as well. That's also fine. So we'll attach to T1, this T1, and call that whatever you like. And this means that we are, by attaching this as an extension method to a generic, we're attaching to everything in the entirety of C#. And then the only other parameter we take is a func, that being a delegate type. So a func that turns whatever the T input, the T1, the tprev, into the T output type. And that's a func, which we ask the user to pass in. And then literally all we do is call that func and pass in this, whatever this is, and that's it. Done.
Is that pretty much the same as select, except that rather than working on a collection, you're working on a single object?
Yeah, that's exactly it. So the concept is pretty much exactly the same as select, except if you did, I'm calling it map, call it as you wish. I've heard it called all sorts of stuff. A chain is another thing I've heard it called. I've heard it called bind. I've heard it called bind. I like map. I think map's nice and friendly, but call it as you wish. Yeah, the only difference is, let's say that you called map on an enumerable, then when you put in your lambda expression inside map, instead of it attaching to each individual element of the whole enumerable, it would attach to the whole enumerable at the same time. So X arrow would be, X here would be a whole enumerable. Now, you probably wouldn't use map on a whole enumerable because there's not many times when you'd want to do that. You probably want to use select. Map you could use it on your string to change your string. You could use it on your complex class to do all sorts of interesting things to your complex class, to convert it from whatever the old complex class type was into another one and into another one. You could do a whole series of operations. But the whole point is that all we're doing is give me a function, turn the old one into the new one, and then you can chain them one after the other, which doesn't seem like a lot. But then when you start actually using this thing, it is incredible how much you can compress your coding down for a start. You can convert an awful lot of functions that you've written, longhand as it were, down into just a single arrow function with a couple of maps to do a set of conversions. It's marvelous. But this is a monad. That's what one is. So your map function out in the extension method, that's the thing that's doing it all. It's like this little wrapper around a series of funcs, which gives you a space where you could perhaps even put some logic in, which is where we take this process a little bit further. So imagine a bit further, and we didn't have just a blind let's do this thing. The next step is to create something. Now, I've heard all sorts of names for this. I tend to call it maybe. I've heard it called option. I've heard it called all sorts of stuff. But the way it's described in the Banana book, and this is great for C#, is you create an abstract. So you create an abstract class, call it maybe, and inside your maybe, you put a value, call it t. So you're going to make this class a maybe of t, that being a generic, and inside it you have a t value, t item, whatever, and inherit off it twice. The once, call it something, inheriting from your maybe, and your something just is literally a blind inherit off your original abstract class, and then nothing, which overrides your t and replaces it with default. Okay, hopefully with me so far. So imagine this. You've effectively got two states of this thing. The abstract groups them together, but we've kind of got two states now. So then you modify your map. So instead of just saying blast, call the function, call the function, call the function every time, instead we do a check. So now we're only attaching to maybes. So we'll attach this to be a maybe of any type whatsoever. And we still take a function, which turns the old maybe into a new maybe. And that's fine. So it's still in principle the same thing, but you first got to turn something into a maybe to actually access this extension method. But now we check. We're going to check the value inside of this and see, is it a something or a nothing? Using your standard bit of C# type checking. This is we've got a lovely new format in C#8 now. We've got our switch operations that'll do the job just fine. So we'll just check, is it something? That means we had a value or not. If it's a something, then we just behave exactly the same as we did before. If this was a dumb map, we'll call the function provided, and we'll pass this in, and everyone's happy. If it's a nothing, then we do nothing, and we pass another nothing back. And this is amazingly powerful, because what it means is you can chain a series of operations. And the best description I've ever seen of it was from the Scott Vlashin website. He wrote an article called something like, railway orientated architecture or something like that, I think it was called. And he said, imagine that you've got two train lines running in parallel. And you want at the top's your happy path, and that's there was a something. It worked. And then every time we do an operation, there's a point. And the bottom path is the nothing path, the unhappy path, or whatever. And this is where it didn't work. And the point is that every single time that we pass the points, we run the function, see did we get something back or did something explode and we got an error. Then we switch tracks and we switch to the nothing track, and then just glide all the way down to the station with nothing. We do nothing more. If it worked, we carry on trying. So the point is, if at any point one of the operations in the chain fails, then without having to bother to put null checks around it in your real program, it's just implicitly there. The null check, the error check is all now just contained in the structure. You don't have to start branching based on did the previous step work. So just taking away things like null checks and try catches and stuff like that, we're already saving ourselves rooks of programming space and simplifying a huge amount of program down into a couple of lines, which are really, really incredibly easy to read. And you can even pass out the option, the maybe, whatever, as your return type, and then you're telling the rest of the program, here's a thing, I don't know if this worked or not, it's up to you to check and decide what to do with it. So you can get away with all these sort of, because normally what I've ended up doing in the past is something like, instead of returning an object, I return like an operation result object, which contains a nullable version of the object, and like a true false did this work, and something else receives this and handles it. Well, rather than doing any of that, it is now implicit in the structure of our program. Here's a thing. The fact that this is a maybe means it worked or it didn't, and we have a standard way across the whole of our program to check, did this work? So that's just do a check of is something or is nothing, and then we know how to proceed. It's beautiful and it's elegant, and it's something we should really all be using, because it's kind of a way to do away with things like null exceptions and needing to put try catches around disk operations. You could just pretty much do away with a good chunk of all that boilerplate code you've ever written and just lock it into this fairly simple structure. Now, it is a real crushing shame that, of course, people say monad and their eyes glaze over, and you can try looking at some of the very, very maths-heavy technical descriptions of what this thing is, and it just looks like this wild, weird, conceptual thing that no one in the real world would ever use, and yet it is incredibly useful. So, again, returning to so like I said, an engineer's description. Don't worry about the formal definitions. What's it for? How do I use it? It's select, but selecting a whole object. It stops you from ever having to worry about null checks. It stops you from ever needing to worry about things like putting try catches around everything you're doing. It compresses your code right down to just a couple of simple lines. It's marvelous, powerful thing, and give it a go. The best way ever to learn this stuff is just sit there yourself and implement it. And I found it strange at first, and it's not that it's complicated. I don't think it is. I don't think it's complicated at all. It's just a bit of a conceptual leap. And I sat there and I just plugged down the implementation of the maybe monad myself. And at some point, it was just like, bing, light bulb moment. This all makes perfect sense. It didn't even take very long. But from that point on, it all made sense. I understood exactly what this is for, how to use it, why we use it. There wasn't really any complication left to it anymore. Now, it's the only difficulty I've had usually is trying to convince a lot of your sort of what you might call like the older school programmers to pick this up, where they've been deeply and heavily invested in the object-orientated paradigm and don't want to veer away from that. And I don't think in C# we're ever going to do away with object orientation. I don't think anyone is saying that, but there is nothing wrong with adopting some functional programming principles to improve our daily code. I saw a talk a year or two back by Mads Torgersen, I believe it was, on the future of C#, and he said that the whole idea is meant to be that C# will be a hybrid language. So it's going to support object-oriented and it will support functional. And if you have a look, every version of C# that's come out for the last whole load of versions has always had more functional content included. I've given talks on this subject over in the US to interns where they're on like a temporary release from university to come and work for a company. And a lot of them come to me and said, this is actually what they're teaching us in university now. Like, this is like a very much a coming thing, I think. It's one of these where if you don't adopt it, you'll end up left behind sooner or later. And even looking on things like, if you look at the schedules at some of the big conferences, you'll often find that there's more functional content year by year, not less. And functional is even creeping into the non-functional talks as even if it's just an aside to say, and here's for the functional guys. It's definitely not a flash in the pan thing. It's not like any of the many JS frameworks where they've come and they were big and everyone loved them, and then they're gone and you ended up with this useless legacy technology that's sitting in the back of your code base somewhere. I'm sure we can all think of a name, and I shall refrain for the sake of not being too controversial. But functional's not like that. Functional's not a framework at all. It's what's called a paradigm. It's a style of programming. It's, as we've already discussed, it's really flipping old. It's been around since forever. Well, okay, late 1800s. But it's been around for an awfully long time. And I see no reason why it's not going to be around for an awfully long time to come. Now, it could well be that there's a bit of a balance to be struck in some programming languages between how much is object orientated and how much is functional. Now, C Sharp's always going to be a hybrid, I think. If you want to get deeper into pure functional, then there's F Sharp is there for you if you want it. And of course, there are a whole host of popular pure functional languages. You've got Haskell and Erlang. If anyone's ever used RabbitMQ, I believe that's an Erlang product. And supposedly with these pure functional languages, the claim is that they are so flipping solid that once the thing will actually compile, it'll just stay up forever without ever without ever crashing out to end of program. Could be. I've never worked in them, but it's a claim that seems entirely reasonable to me. And who wouldn't want that for their business application? I'd certainly would like a bit of that. C Sharp doesn't support all the features of a functional language. Now, one of them is tail recursion. Adopting a pure functional approach in C Sharp is possible. You can do it. I've done it. You can absolutely do it. You've got to kind of malform it a bit with a whole load of nifty looking extension methods, but it's doable. But the problem you get in C Sharp if you go all the way functional is memory. So you get an awful lot of stuff where you've got an operation which is being suspended in memory, pending on another operation, and so on. When you try to do things like, because in a functional language you would do away with stuff like for loops and for eaches and ifs. You'd pretty much abandon all of those because there's other structures to do, and you'd use recursion rather than your for loop. And you absolutely can do that sort of thing in C Sharp, but it's not optimized for it. So you end up with this massive memory overhead. Now, if the amount of objects that you're dealing with is relatively small, you'll probably never notice the difference. And the gains in readability and how robust the code is are probably worth it. But if you're dealing with a recursive function where you've got thousands of items in your array, it might be that you just simply can't do it. Now, without switching tactics somewhat. So, again, we return to the age-old question, what are you trying to accomplish? And that's where I would start with to decide how functional do I want to go. I love functional, so I would probably always tend towards more functional, but there are places, at least in C Sharp, we're always going to have to make concessions. But then if you switch over to the F Sharp world or something like that, then you don't have to, and everything's functional. It's just you won't be able to retreat back to necessarily making variables read-write and stuff like that because they're going all the way.
Yeah, I guess even with F Sharp, you're dealing with libraries that are designed to just be .NET libraries, .NET standard.
Yeah. So
you've still got to have a bit of a bridge between the functional world and the non-functional world as well.
Yeah, I mean, your other problem with I'm not denigrating F Sharp. I don't know F Sharp. I've dabbled in F Sharp a bit, and it looks really cool. It looks like a thing I'd really enjoy to learn. But one of your problems is always going to, in the business world, one of your problems is always going to be like the whole team has to be happy to support this thing. So that's always going to be your issue is unless the whole team are happy that we're going to take this thing on, then you've got a problem. And then afterwards, you've always got to be sure that you're going to have to, you can bring people in who are going to be happy to learn F Sharp. So I'm not saying that's not an exercise that might be worthwhile because there's benefits to be had. The sort of things that F Sharp does really flipping well is things like your back end, like rule engines, however you might call them. The thing where it's just, here's a chunk of data, turn this into another chunk of data, or make a decision and give me back the decision. This sort of raw data to other data stuff, F Sharp does that tremendously well and probably better than C Sharp. So if you've got a whole load of that to do, there might be something to be said for even going down the hybrid route of write all that stuff in F Sharp and then everything else in C Sharp, maybe. Although I know you can do everything in F Sharp pretty much that you can do in C Sharp. You can have a web front end on it. You can have input output. You can have all that stuff in there. But at least with the hybrid approach, you've got this slightly more comfortable, familiar C Sharp wrapper around maybe a less familiar technology. Because everyone, well, that's not totally true, but enough people know C Sharp that it's not much of a risk to adopt. You know, go to a dev conference, chuck a rock, and you'll probably hit someone that knows C Sharp after you've finished apologising to them. But yeah, you know, it's
don't do that.
Yes,
any of our listeners, don't do this.
Yes, don't try this at home again, because you know, obviously, I would never do that. But yeah, absolutely. So I've got friends that swear by stuff like Haskell and all that stuff, and I've got no problem if we all want to go down that route too. I've heard it's great stuff. I've never yet worked with anywhere though that used it in production.
So like each time we chat, and I think this happened in the DDD episode as well, it came up about your talks involving food in some way. There's another term called currying, isn't there? I don't think we've touched on that so far.
Yes,
but that again is making me hungry. So every time I chat to you, there's
it's really not a planned thing. It really isn't. And in fact, currying has got absolutely nothing to do with the delicious food from South Asia at all.
I'm so disappointed.
Yeah, I know. It's a total coincidence. It's named after it's a gentleman's first name, isn't it? No, it's his last name.
It's not Haskell Curry.
Haskell Curry. Haskell Curry, it's his last name, yeah. So it's a gentleman's last name, Haskell Curry, who's got something like 3 different programming languages named after him, Haskell being one of the other ones. I can't remember what the third is. I'm sure it's out there. But yeah, currying. So currying is an important functional concept, and it's really awesome if you get a chance to play with it. C# doesn't really do that. I think it's slightly too rigidly defined to allow for it. So again, I'll go back to the simple example I usually give in my talks, and that's, let's imagine for a moment that we have just a simple add function, and we have like int a and int b, and it returns back a plus b. That's really, really crazy simple to understand. That's fine. We've got no problem there. But let's imagine for a moment that this was, entirely hypothetically, a curried function, and let's call it add. We're calling it add for now. So if I called add and then just gave it 10. Now, if I tried doing that in typical C#, that would actually just be a compiler error because you haven't given the second parameter, or else, I'd have to go and write an overlay, whatever. But in a curried function, that would return you back a function which adds 10 to whatever you give it to. So you had 2 parameters. By providing one, you filled that in. Now you get back the function again where A is filled in and B is still to be filled in. So you have turned it into an add 10 function. Now that's probably a slightly ludicrously simple example, but you might well use that. But it's another way of combining functions. Again, like if you want the Lego analogy where you're clicking them all together, you could have functions. It allows you to reuse stuff. So if you had a function that had 4 or 5 parameters, and each of them determined how it behaved. I usually give examples of things like parsers, where it's like splitting a giant text file by line and then by field, and then doing some conversions and doing some other stuff. You could just write, rather than writing a whole load of different parsers with different combinations in it, or you could just pass it a couple of parameters of that, and now here we go. 2 parameters are filled in. This is a function that will always split something by new line and comma. Fill in the rest of the parameters and don't worry about calling all the rest of it every time. It's just another nice, nifty way of reducing the amount of code we need to write and of clarifying the intent of what we're doing. You can reuse the same literal function many times, but you can use it as if it were several different functions with the first couple of values filled in. You can do this sort of thing with C#. It is possible. It's a great big bit of a hack though, and it involves turning all of your functions into funcs, and then writing a whole load of extension methods that convert like a func with 4 parameters into a func with 3, and 3 into 2, and 4 into 4, and 4 into 2, and so on. Every combination you can imagine of how many parameters going into how many parameters going out, you'd have to go and sit there and write all those extensions. And then every single time you just pass back a func with the appropriate number of parameters going out. Totally all doable. I've never really done that in production though, because it's possibly a little bit more of a conceptual leap, I think, than perhaps some of the folks I work with are ready for. But if you switch out of C# though, you'll find it being used in an awful lot of places around and about. So obviously the functional languages all use it. So if you go into F#, you'll find that everything's curried. And that's great, so you can use it there. There is a rather marvelous JavaScript library called Ramda.js, which is one of my favorite things ever. It's marvelous, and It's kind of like an alternative to something like underscore or Lodash, but it turns everything into lovely functional curried functions. And you can write some really, really wild code with something like Ramda. I recommend anyone to go check that out if you want to have a really nice play, which you can actually do in your day job because it's JavaScript and everyone's got JavaScript. And you don't need to learn a whole new language to do it. Or you could go and do your extension methods, but it's in C#. But it is a little bit, like I said, that is a lot more of a hack, but it's still possible.
Even the name Ramda, I'm not going to forget that, so I'm going to have a play with that. That's funny.
I'm a big fan of that particular library. Yeah, I mean, its symbol, its logo, I think, is a ram. It's like a lambda, except it's a sort of clever pun.
Well, I'll definitely have to have a play with that, and I will include a link to that in the show notes.
Awesome.
So we've explained what a monad is, and you gave the very basic example of just a map function. But where you've used other things like maybe, which adds success failure states to that, is that part of what a monad is as well? The fact that it can abstract away side effects?
Yeah. I mean, your success failed. I mean, that's all monad. The maybe, the map, that's all monads. And when I say that promise is a monad, there we go. There's another one for you. That again, you're abstracting away the fact that we are waiting on an operation and it might fire with a success, it might fire with a failure, and we don't know when. That again, we're abstracting away the execution of the function from what the function is. It's actually encouraging the separation of concerns to a level that isn't otherwise possible in pure object-oriented code. But there are many monads out there. I mean, another one that might be of use to everyone I've heard called either. And so rather than having your maybe is something or nothing. So if you want something that's going to give you a little bit more facility for debugging, we can move into the either, where instead of something or nothing, we've got left and right. Left being it didn't work, and that's your nothing, and right being it did. But then rather than just having the original, the final output object or literally nothing, you could have, for example, the right hand path, the happy path. That's pretty much exactly as we have before, because if it works, then who really cares about anything else? But on the left hand path, then instead of a nothing, you could have, for example, the last value that worked. You could have any error messages that were received at that point contained it. You could modify the left or inherited class to contain anything you want. It can have any number of properties you want. You could have any amount of debug information, time and date that the problem occurred. Whatever. The sky's the limit. And then once you pass out the either, you could then receive this either and then do your typing check to say, is it the right hand path? If it is, just carry on. If it's not, then pass it along to debugging and then report all the details of what went wrong. And if you've been good and you've been writing all your methods as pure, then you have the marvelous ability to completely replay the exact state that the error occurred in. If you've captured the error, the item in its last good state, and the next function was a pure one, then we can literally recreate the error precisely as it occurred in a unit test, fix it, back into production, everyone's happy. So we're reducing the amount of effort that would typically be required in trying to recapture the state of the system at that point. A function in the functional world is not supposed to depend on anything besides its input parameters. Now, if we've captured all of them, then there we go. We literally can recreate precisely what happened.
So where we're talking about all these maybes and things, presumably these are just going to be sitting in some library or a set of utility classes. So we've spoken about the maybe implementation, but as a user, you wouldn't have to worry about that. We would be left with almost link-like functions, which say do this, do that, do this. And we don't need to have if no in between each of these chained calls. It sounds like we're going to be left with really, really simple business logic, which makes it really, really readable.
Yeah, that's exactly it. I usually use the analogy of the proverbial snarf action figure, which you might have had since you watched Thundercats in the 1980s. I couldn't.
That brings back so many memories. In fact, I think I'm going to go on YouTube later and watch them.
Just whatever you do, don't try watching the new remake version of Thundercats that's just come out.
Is it bad?
Oh, yeah.
I'm gonna have to watch it now. You said that just out of curiosity.
Okay, but don't blame me. I did warn you. But anyway, yeah. So my point being, though, that your hypothetical snarf action figure, maybe you don't want to get rid of it for the sake of nostalgia, but also you maybe don't want anyone to see it, because who wants to admit to liking snarf? So you keep it in a box. You keep it in a box. It's somewhere in the house. You know it's there. You don't need to see it, but you know it's there. And that's my metaphor for you. The stuff, the sort of extension methods I write for doing my functional programming stuff, they exist somewhere in the project, and I will usually shove them somewhere way to the back of the code base where I don't really need to ever look at them ever again, but I know they exist. And I usually write them so abstractly that I could drop them into any project. And if you have the facility to do automated builds, then you might well create a common library that everyone can inherit, and provided you make them really generic so that once you've written as one of these, you never need to touch it again, then the risk to your project is relatively low there. You're not needing to update everybody everywhere because something significant has changed. It shouldn't hopefully ever change once you've written it. So yeah, it's a relatively low risk investment to save yourself heaps of code.
So are there existing libraries which already implement these classes for you, rather than having to do it manually yourself?
There are. I've dabbled in them a little. Now, I've personally always found it more of a beneficial exercise to write myself, because I like to understand it. I have my own particular way I want these to behave. And honestly, most of these extension methods are so small that it's not like much of an arduous task. But yes, there's one I've had a mess with a little. It's called Language Ext, and it's not all that different to the stuff I've been describing. One of the differences is that I would consider passing out a monad as a return type if I wasn't sure whether the operation was going to succeed or not. I think they give you a facility where you can have a function at the end that collapses your multiple states into a single value based on, I think you pass it in several different funcs, which are like, this one would be called if it was a left, this one would be called in a right, something like that, and it collapses it down into a value. So yeah, absolutely, you could do something like that. I find it's a lovely, useful exercise to do it yourself, to handcraft how you want the monad to behave, and just to understand how it behaves, because I think that's as valuable as anything. Because it's not all that hard once you've clicked on how it all operates. And once in a while I find myself writing an entirely new little extension with a highly specific alternative form of operation, particularly if you do something like the advent of code, where I'm having to do things like aggregate until this particular value occurs or something like that. So you can write all sorts of funny little potentially useful functional extensions onto your language. Oh, aggregation's another thing to look into, by the way. This is something that's been in C# since like C# 4 or something like that, and it's chronically underused out there in the big wide world. And again, it's a fairly functional idea where you're just starting with a list of values and you're telling it, here is a function which says, given the previous running total, here's what I want you to do to convert this particular item into the new running total, and then it just goes through the list one at a time, converts a great big list of items into a final single result at the end. I can't remember the last time I actually wrote a for each loop. Link pretty much does all that stuff for you if you let it.
I like the way with ReSharper or Visual Studio, presumably now, if you have a for each, you quite often get a little squiggly saying, would you like to convert this into a link statement? And I often expect Clippy to pop up as well.
Risen from the grave. Visual Studio itself does do a lot of that stuff now, although obviously it doesn't hold a candle to the sheer depth that ReSharper goes into. And we haven't got our ReSharper licenses where I am at the moment. I'm looking forward to them. They're on order. Ooh, it's going to be nice to be back in ReSharper again, because it's incredible. I actually learn a lot of features of C# first by having ReSharper gently tugging on my sleeve, telling me there's a slightly better way you could have done that. I'm hoping that I'm I'm doing a reasonable job of keeping up with myself, but it's always nice to know, that one new dumb trick that every developer should know.
Yeah, I quite often find when I'm working on a shared code base, and I use ReSharper, well, I actually use Rider, but it's got ReSharper, the ReSharper engine. You always know code that's been worked on by someone that's not using ReSharper because it's full of squigglies and improvements or suggested improvements.
Yeah.
But as I say, I've used ReSharper for that long. I don't know what functionality that I just used that didn't used to be in Visual Studio, which now is. So it's possible that Visual Studio has come a long way and maybe caught up, but I just don't know because I've become so dependent on ReSharper.
I've been using just pure Visual Studio 2019 for a while now, and it's good. It does give good hints, and it does have some nice, little shorthand operations you can do. It's all great. It's a world away from what it used to be when it was like you had to know all the libraries yourself to do using statements and all the rest of it in the old days. Back when we all started this, and you had to have a small short list of knowing what belonged where and all that. No, it's come a long way. And it's definitely taken on aspects of ReSharper. But I think, of course, the difference is that with ReSharper, that is what it does. And that is the sole thing that it does. So, of course, it's an awful lot better at it. It goes far deeper into your code base than just Visual Studio alone can go. So I'd absolutely, if anyone gets the chance, if you haven't already, do have a play with ReSharper. It is fantastic. And if nothing else, it's got a wonderful test runner as well, and various other features that I'm not sure how I'm coping without.
I quite like the continuous test runner in ReSharper and Rider because it's pretty much the same thing. And you can, if you've got either all your tests or just a selection of tests, if you've used nCrunch in the past, it's very similar. And so you've got a session of tests which you can run manually. In the toolbar, there's a drop down which you can tell it to automatically run the tests every time you make a change. So as you're coding away, every time you save the file or build, it will just automatically in the background run all your tests that have been affected by the code you've just changed. So you get that immediate feedback if you break something. It's really nice.
That does sound pretty good.
When I say feedback, they've actually got coloured dots in the gutter of your code. So it's red if a test has failed, and it shows this both in the tests and in your code itself. It's green if it passes, and white if there's no test covering that code. So you immediately get that view of, does this production code have any tests against it?
I just went misty-eyed. I really did. That sounds really cool. I want it. I'm a big advocate for test-driven development, as several of my colleagues really have come to learn to their detriment. But I'm a massive fan of it, and we'll talk about it at length. So the company I'm in at the moment it's not a thing they've historically ever had, although I think it's something they're keen to get into, and that's great. That is the right attitude to have, and I'm hoping I will be able to help them with moving more into that direction. I personally feel that once you start going down that path, once you've gotten into it enough, it just becomes a natural part of your development style, and it starts to become hard to not use it. Because I some years ago I was working for a company that were incredible in terms of how up to date they were in their development styles, in their development practices, and they had a policy that if there were no tests, your code is suspect, and that was great.
It's true.
Oh yeah, I like that attitude. It's good, and I went away from that, and it felt like, oh my god, it's like walking up a mountain and someone's taken all the safety rails away and torn up the nice wooden footpath for you to walk on, and everything's slippy and nothing can be trusted anymore. And it was actually very hard to adjust down to that level of risk being introduced into a code base. Like, I could change this over here and I'd never know if I introduced a bug. It's mind-blowing.
My current contract is 100% TDD, and this has really taught me the value of TDD. And it's scary, exactly like you're saying. Every day, the tests, as I'm coding, the tests are finding bugs. And I'm thinking, hold on a sec. How did anything I've written in the past get into production? Because it's scary how much, as you're coding, it's just catching them, finding them. And most of them I would have just noticed a few minutes later when I tried to run it. But there's some which I would have never spotted if it wasn't for these tests. Another thing that I find is, for a long time, I've written or tried to write testable code using solid principles, all this kind of funky stuff. And then so I've kind of, in my own head, code is testable, I can then afterwards go and write some tests against it. That never happened because the new requirements always came up. And there was no point in making it testable in the first place because most of the time the test didn't get added across all of the requirements. Where one of the advantages I found with TDD, just doing the test first, is when you get into that habit, that goes away because you can't forget to do it afterwards because you've already done it.
Yeah, no, absolutely. If you do it afterwards, it's all one big long tedious exercise because my code's done and I know my code's done, and of course then you can overlook things, you can not realize, because I know my code works because I tested it myself. So I might not bother to do it yet. Well, you might not actually phrase it in those terms in your head, but somewhere it can end up happening. It's easily done. Returning on topic, functional programming is a huge enabler of things like TDD, and this is for a lot of people one of the big selling points. It's the fact that it's just so flippin' testable compared to the alternative. It's so easy to set up tests because if your function purely relies on its own parameters, you don't need to do mocking. I've heard tell of people who've written entire applications and test suites without using mocking at all. Now, if that's perhaps a little step further than I would go to use zero mocking because sooner or later you're going to have to make some sort of strange compromise to make this thing work. But it's certainly possible to reduce down the amount of, complicated, expensive setup that might be required for a lot of systems if you go down more the functional route. And the other thing it enables is concurrency. So if one of the big problems, if you've got multiple processes all running side by side, if there's some shared state or some shared object that everyone relies on, then of course you're going to get resource contention or race conditions or something like that. But that doesn't happen in the functional world it's probably possible as some sort of very complicated and emergent property. But generally speaking, anywhere compared to the object-oriented world, it generally doesn't happen because here are my parameters. I will operate on these parameters and then pass this predictable thing back. It almost seems to me to be common sense to operate in this manner. It's just so much easier for no actual cost as such. And obviously these days, concurrent programming is becoming a more and more important thing. We're going into the world of containerization and just having hundreds of microservices all lined up side by side with each other. And this functional programming enables that sort of thing rather nicely.
Yeah, definitely. It definitely sounds like the way forward. I'm aware that we're on par for being one of the longest episodes we've done so far, so we probably should start wrapping up. But did you mention that you're up for doing a DevTip earlier?
Yeah, I actually have two, if you have the patience. A technical and a philosophical. So for a technical, I am a big fan of just learning in general. As anyone that knows me will know, because I can talk your ear off about any number of subjects. But amongst other things, I learn a lot of languages, and of course, there's my technical learning. There's all sorts. I learn music. There's all sorts. I'm always learning because fundamentally I enjoy it. And one of the best apps I've ever discovered for learning anything, this is universal, is an app called Anki. Anki, I believe. Anki, I believe it's Japanese for remember. It's a flashcard system. It's staged repetition flashcards. So you write yourself a block of flashcards, and it's got an incredibly rich option set for every card. You can have cards that are dependent. You can have the cards themselves can have HTML on the front or the back. You can have images, videos, or in my case, 99% of the time I just embed text. But fine, you can do any amount of styling and information that you want. And then what it will do is you tell it how many cards new do I want today? How many do I want to repeat from my bank of old ones? And it has a system where the more you get one right, the less often it will ask you. So if you just keep getting this one right, it's not going to bother asking you. If you get this one wrong every day, it'll keep asking you until you start to remember it. And then slowly it's moving from your short-term to your long-term memory and learning it. So I've used this to pass exams. I've used this to learn German. I've used this to learn music. I've used this to do all sorts of stuff. So anything that can be a flashcard in any sense where there's a thing on the front which is prompting you and a thing on the back that's the answer, Anki is absolutely terrific. And the neat thing is it's got the desktop app and the mobile app. So what I would do is go onto the desktop, write all my cards out, or import them from a CSV, which is what I normally do, and then press the synchronize button, and then they're on my phone. So if I've ever got a bit of dead space when I'm waiting for a lift or whatever, I can just pull Anki out and just start doing some flashcards. And I've learned a phenomenal amount of things that way. So that is something I'd recommend to anyone who, like myself, enjoys learning or just has to.
That sounds amazing. Can you actually share cue cards with other people so you can learn off each other?
Yeah, I don't think there's any automated system for send to user X. I don't think that exists. But what you can do is export your words, your card set, and then pass that on to someone else. I think you do stuff like that. And I suppose probably if you were a teacher, say, and you had your students, you could probably write an Anki set in CSV or similar, and then just pass it around. I believe under the surface, it's actually just a MySQL database, the cards. So, and it's also extendable. You have to write extensions in Python. I don't personally know Python very well, but I have written a few extensions just by kind of hacking about with it. So there's all sorts of stuff you can do to extend it out. Even to there are extensions out there that do things like turn your flashcards into a sort of crude war game, where you have to get cards right to be able to move your troops around and stuff. There's any number of daft things you can do with this. So I would very much recommend anyone to give Anki a go there. The second is a slightly more philosophical, and it's a principle. It's one of the many principles I've worked to in all my life, and that is, if you look at a bit of code and something in your head is saying, that could be better, you're right. You're absolutely right. You could be better. And if you've got the time, go ahead, learn something new, work out how it could be improved, and then come back. And there you are. You're a better developer, step by step by step.
That is a very good dev tip. I might actually follow your lead and do 2 as well.
Uh-huh.
So my one I was going to do today was basically just, we all use regular expressions, and there's a really nice site called regex101.com, and it's just a web app. And it's a really nice UI where you can run different tests. You can enter a whole block of text. You've got syntax highlighting as you type in your regular expression. And it shows all the matches and the groups and things. It's just a really nice, very quick go-to website when you're working with regular expressions. I must admit, I'm probably a bit on my own in the fact that I quite like regular expressions. They're insanely powerful, but especially when you come to one that is a bit more complicated, it can be a bit mind-bending.
No, I'm absolutely with you. I don't think I've used that particular website, but I use one very similar to it for the exact same purpose. And again, moving back to Advent of Code, there's times when, I've been laboring away for hours writing this incredibly complicated C# code to just quick parse a string, and then look around online, someone did a regex that's about 12 characters long and did everything that you just did. It is incredibly powerful. And again, I think it's one of those things it's rather chronically underused out there in the wider development world when it can do so much for us.
So my second dev tip, which is more on topic for tonight, is, and this was quite a while ago, I got shown this by one of the .NET Oxford regulars, Tom Dutton. I hope he doesn't mind me mentioning his name. He showed me a website. It's also a language called Darklang. So on Twitter it's @Darklang, but their website is darklang.com. And this is a highly functional language, but you can drag and drop the functions around, and it's got a really funky UI, and it's really hard to explain in the podcast. But if you go to darklang.com, I can include a link in the show notes. Then they've got a demo video which shows it off, and it's quite mind-bending, so it's definitely worth a look at.
Yeah, I'm having a quick look. This does it, and I noticed they credit the same Scott Volashin talk I was talking about with the railway-orientated programming. So they're clearly on the ball in terms of the functional stuff. This is something that I think I need to have a dig through myself.
It looks very, very cool.
It does.
When Tom showed it me, I added it to my list to actually properly dig into, but as with everything, it's a long list. So I think this has reminded me to actually have another dig because it looks so cool. Cool. Is there anything else you wanted to mention before we wrap up?
Just quickly, I forgot to talk about pattern recognition, which, to be honest, as of C# 9, it's pretty. If look into the new statement style switch statements and have a dig deep into a deep dig into those, and you'll pretty much understand what that's all about. It's just incredibly complicated, powerful switch statements where you can switch on properties and stuff like that. And again, significantly reduce the size of your code base, because honestly, C# 9 is lovely. I like C# 9. So do check that out. And other than that, just stay safe, folks. It's been a flipping tough old year that we've just finished. I have this feeling like the world came close to hitting rock bottom at some point. So it is my hope that this next year, at least, I'm hoping up is the only direction we'll be moving. Fingers crossed. So stay safe, folks.
Yeah, I have a bad feeling it's going to get a bit worse and then get better. But I suspect it's going to get a little bit worse before it gets better, unfortunately. But we've just got to hope that, I think it comes down to the vaccine, to be honest.
Yeah, at the very least, it feels like with not all the huge problems that we're facing, but with many of them, it feels like a corner has been turned at the very least. And it might take a bit for the momentum to actually, affect us day by day. But it does feel at least like there's some hope in the world, where certainly there were points in 2020 where it just looked like, oh God, what now? Like every time BBC News headlines popped, it was like, what now?
Oh, it still feels like that at the moment, but as you say, there's definitely, hopefully anyway, a turning point on the horizon.
Definitely. Keep your families close, folks.
Definitely. Cool. Well, thank you so much for spending your New Year's Day and joining me to talk about functional programming.
Great. I'm probably have to go back to the kids and wrestle my oldest daughter off Fortnite and convince the younger one to stop watching Ryan's World now.
Yeah, well, I've been having people lean in, as you probably saw, saying, "Come on, dinner's ready, dinner's going cold." But
yeah, my lunch was actually ready before I came here, so I'm just going to go and have a late lunch now.
Oh, really? Oh, so sorry.
No, it's fine. To be honest, if I'm still on holiday, I've been grazing more than I probably should. But back to work on Monday, and I'm going to be being a bit better with my eating, I think. But for now, at least, hey, everything goes.